Okay, everybody, these are the solutions, partially or mostly, to the myAP problems that we had for this past week. So here we go, and you can kind of fast forward to whichever ones you want to see. So we'll start here with problem number 1. And problem number 1 gave us a gigantic chart and then asked us to find the first degree Taylor polynomial about x equals 2. Well, here's x equals 2, so we're going to be looking at this piece of the chart here. And we're only looking for first degree Taylor polynomial, which, if you think about it for a moment, is really just a tangent line. But if we set it up the same way we do Taylor's, we're going to do a 0 and a 1. We're going to get a first derivative. Now, these are h's, so we're going to have just h of x, and we're going to have h prime of x. We're doing these at x equals 2, so h of 2 is 80, and h prime of 2 is 128, times 1, this is the 1 over n factorial piece, and another 1. No x's here and an x here. So we end up with 80 plus, this is not x, this is about x equals 2, this is x minus 2. That's what the polynomial piece is, 128 x minus 2. That's our polynomial, I'm going to call it p sub 1 of x. We could do that, but that's our first degree. Then they ask us the follow-up question. Use it to approximate h of 1.9. So that's going to be 80 plus 128, 1.9 minus 2. Now you could use a calculator here, but 1.9 minus 2 is negative 0.1. That's 1/10 of this value, so we get 80 minus 12.8, and that's going to be 67.2. And the final question is this h of 1.9 value greater than the real value of h of 1.9? We want to explain our reasoning here. And what we're dealing with is, because all of the derivatives, if we look here, everything is positive along the way. So this is concave up. We know that in a concave up curve, the tangent line sits below the curve. That's why this is going to be an under approximation. And that's it. So that was question number 1. Now we're going to take a look at question number 2. And question number 2 asked us, give me 1 second, everybody. Sorry about that, something dropped. Okay, so we're looking for a second degree Taylor polynomial, and this time they're giving us the derivative of the function, y is equal to f of t, and they give us one value of this function, f of 0. So we're trying to find second degree Taylor polynomial. If we do this the same way, we set up our 1, 0, 1, and 2 this time, we're going to second degree. We're going to need an f of t, an f prime of t, and a second derivative. And we would need to go further, but we're only going to 2. We're doing these about t equals 0. It's helpful because they give us 0 information. So f of 0 is 8. The derivative of 0, well, f prime, this is f prime right here. So we're given f prime of t basically as y over 8, 6 minus y. And we know that when t is equal to 0, y is equal to 8. So when we substitute in my y equals 8 here, we get 8 over 8, 6 minus 8. That's 1 times negative 2, which is negative 2. That's the value of the first derivative when t is equal to 0. Finally, we need the second derivative. Well, how do we get a second derivative of a function? We take the derivative of the original function. Well, here's our first derivative here. I'm going to multiply through by y over 8. So our f prime is now 6/8 y minus 1/8 y squared. If we go ahead and multiply everything through here, This would be 3/4 y minus 1/8 y squared. Now I can get a second derivative. Keep in mind, though, these are derivatives with respect to t. So when I take derivatives of y's, that's going to be implicit. Therefore, I'm going to get 3/4 derivative of y is y prime. And we know what y prime is. We just found it. Minus 2/8 y and another y prime. There's the implicit piece right there. We're trying to find f double prime at 0. Well, here are things we know when t is equal to 0. When t is equal to 0, y prime, which is f prime, is -2. That's 2/8 is 1/4. Y, when t is equal to 0, y is 8. And y prime, we just said, was -2. So we evaluate all of this, and we get 5/2. You can go through that on your own. So the value here is 5/2. We need to multiply this by 1/n factorial. For 0, that's 1. For 1, that's 1. And for 2, it's 1/2. These are my coefficients. And finally, we'll multiply by not x's this time, but t's. T to the 0, t to the first, t to the second. So there's a little bit of work here, and we end up with a second degree Taylor polynomial of 8 minus 2t plus 5/4 t squared. And we again could call this P2 of t. And that's our approximation. Finally, we're asked to then use this to approximate f of 1. So when I plug in 1 here, we put in all the 1s, and we get 29/4. And that's question number 2. Question number 3. This time we're given a polynomial, 4th degree Taylor polynomial. We have all the derivatives we need, and this is done about x equals 4, but we can see that with all the x minus 4s. We're looking for f of 4 and f triple prime of 4. If you can't see that, sorry, that was hard to read. We're looking for f triple prime. But here's what we know. From the development of Taylor polynomial, we know that f of 4, that's the original function, shows up in the very first term. And the first term really would be f of 4, this is the 0th derivative, so it's just the function, times x to the 0 divided by 0 factorial. And what I can see is that's going to equal 7. Well, these are both 1s, so f of 4 is just 7. When I move to the third, we know that the third derivative at 4 times x to the third, not x to the third, excuse me, these are x minus 4s. This was an x minus 4. Divided by 3 factorial, we know that coefficient, when we come up to the third one, here it is -2. So that's the coefficient. I'm not worried about the polynomial piece. It's the coefficient. So f triple prime of 4 divided by 6 is -2. F triple prime of 4 is -12. And that's it for number 3. And we'll take a look at number 4 on this video, and then I'm going to stop this video for the moment. So here we go. We're looking for the 4th degree polynomial, and they're giving us a lot of information. They're telling us what the first derivative is in terms of the function at 0. So here we go. We set it up the same way. 4th degree, 0, 1, 2, 3, all the way out to 4. And what do we need? We need f of x. We need first derivative, second, third, and finally a 4th derivative. These are all about x equals 0 this time, so that's good. We're going to evaluate these at 0. That's what we need. Well, f of 0 is 2. They tell us that. F prime of 0, I'm going to expand and just do the work here. They tell us what f prime of 0 is. It's f of 0 plus 0 plus 1. I'm just using the formula that they've given us. Well, f of 0 is 2 plus 0 plus 1. That looks like 3. F double prime. Well, to get f double prime, I'm going to go back and take the derivative from here. So f prime of x is f of x plus 1. Taking derivative of both sides, we get f prime of x plus 1 plus 0. So when we're looking for f double prime of 0, because that's what we need, it's f prime of 0 plus 1, but f prime of 0 we just found, it's 3. So this is going to be 4. When I come down to the third derivative, I'm going to come back to here now. Third derivative is derivative of both sides. It's the second derivative, and that's it. Derivative of 1 is 0. So the third derivative is the same as the second. Therefore, it's also 4. And when I do the next one, the fourth derivative is the same as the third derivative, which is the same as the second. It is also 4. Oops. So here's all the work we just did. We'll just move that aside a little bit. Okay. Finish this thing up here. We're now going to be multiplying these by the 1 over n factorials. For 0, that's 1. For 1, that's 1. For 2, that's a half. For 3, it's 1/6, 3 factorial. And 4 factorial is 24. Finally, x to the 0, x squared, cubed, and fourth. Multiplying it all out, we get 2 plus 3x plus 2x squared plus 4/6, that's 2/3 x cubed, plus 4/24, 1/6 x to the 4th. That's it for problem number 4. That's going to be in for this video. I'll put the last two up at some point in the very near future.